Yeah, so Ian, good afternoon. Ian, good afternoon. Good afternoon, Ian. Can you hear me? Ian, can you hear me? Ian, are you still on call? Ian, good afternoon. Ian, can you hear me? So good afternoon, Ian Masik. Are you in class? Are you on call?
Yes, I'm in class.
Oh, thank you very much. So seemingly The rest are still not with us, yeah? So I think we can just proceed, yeah? Right?
Okay.
Yeah, we just proceed. I think they can catch up with us along the way. Now, what had we discussed in the last class? What was that discussion? Was it about that long question in December 2022 exams?
There was one we did for NPV, and then we used the alternative approach, the long approach for getting the PVs.
Also, so we had not finished on that. That was sensitivity analysis, if I'm not wrong, yeah?
Yes, yes. Then we started. You had started now explaining the sensitivity, the definition.
Okay, so also in that question we had only done part. I think we had only done part A of the question, where we computed NPV, and then I
Yes.
thought about the alternative long approach, isn't it?
Yes, yes.
I think we had still part B and C of that question to do. So
Yeah.
let's get back to that very question.
Yeah.
Let me just access that from, okay. Yeah, so if I'm not wrong, is this the question you are attempting?
Yes, yes.
All right. All right. So I think with that we proceed. And so the next thing we were to do is this number 2, yeah? Where we are told to compute the percentage change in the following to then reverse the decision in one above. And then we are told to interpret your answer. 1, we have the initial outlay. Number 2 is the salvage value. Number 3, the sales revenue. 4, we have variable overheads. And then number 5, we have the fixed overheads. So we can continue with that solution and continue with the solution. And see that we now have number 2. We now have number 2. Yeah, so allow me to repeat a bit on what we had done in number 1. So that in number 1, we had computed NPV. Especially, we calculated that using 2 approaches. Of course, the normal NPV function. And then we also looked at the long approach. Yeah, so that under the long approach, of course, I had these items. Of course, I had these items. So I had those items. Yeah, so if you remember, I had their present values, which were these figures. You don't have to repeat this, Ian. I just do not have the workings from the previous class, yeah?
Yes, yes.
And the figures which we had computed let me just go through them very quickly. Like now, this one was a PV in bracket. The rate was what percent? The rate was 15%. Comma NPA was 3 years, comma 0, comma negative this one. So that's what we got. And then of course for the sales revenue, that equaled PV into rate of 15%, comma NPA we had 3, and then negative this figure, and so we had that 1.3 million. And then this one is equal to PV in bracket rate is 15% still, comma 3, comma this. These ones we now want as a negative, and so I will let them remain negatives. The same formula applied to that. When we added all this, we got about 532, which if from we deducted the initial outlay, was 500,000 shillings, I believe. So that is a negative. And so NPV, that was 32,000 and change. Please confirm that that's what we got.
Yes, that's what we got.
All right, so with that, I think we can continue to then what is required in number 2. And number 2 wants that we compute the percentage change in the following to reverse the decision made in number 1, and then interpret what? Your answer, yeah? Now, first of all, what was our decision criteria? When we have positive 32 million NPV, is the project viable or not?
Viable.
Yeah, so it's viable. That's viable. In this case of number 2, yeah, we are looking for the percentage change. We are looking for the percentage change. When we talk of the percentage change in those listed variables under number 2, we are talking about what we can also call sensitivity, what we can also call sensitivity margin. So we are looking for the percentage change or the sensitivity margin of cost to reverse, the decision in 1, the decision in part 1. The percentage change is normally determined using a formula that goes that NPV, you divide the NPV by what? You divide the NPV by the present value, of the factor. The present value of the factor by the present value of the factor. In that case, by factor, what do I mean? I mean these variables which makes up the NPV. That is what I mean. The factors which determine NPV are what in this case I am calling what? Factors. When I talk of the PV of the factor, like say for the initial outlay, then we are looking for the present value of cost of the initial what? The initial outlay. And so based on that, how do we then compute the required percentage? We are going to say that we have the first one A, the first one A, the first one A, and actually I can copy these things from here, just copy paste. So that for each of them, what we are looking for is this which we are calling the percentage change. That which we are calling the percentage change. I am saying that for us to compute it, yeah, then of course this is the formula which work with. That's the formula which work with. So that how does this formula work? In the case of the initial outlay, we shall say that this equals what? You know, you have to remember that our NPV is this figure. So I take that, I divide it by what? By the present value for this factor. We are now talking about the initial outlay. The value for the initial outlay is normally the same as the present value, yeah? So if the initial outlay we were told is 500,000, then the present value for it is also half a what? 500,000. This is a negative, and so I will convert that to a positive. So I'll start with the negative. I then pick the 500,000. So that I am introducing this negative so that I convert the 500,000 to a positive, because I'll want the percentage as a pure positive. And so what does that give us? That gives us a 0.06. Because we are looking for the percentage change, convert that thing to a percent, yeah? And how do you convert that to a percent? You can just highlight it, then press this percentage thing up there. Under this option, pick the percentage. So you realize that this comes to about what percent? About 6%. And what is the interpretation of this? Because we had said that we interpret the answer as well. So what does the 6% mean? What the 6% mean? Now remember that we are looking for the percentage change that will make us reverse the decision in part 1. The decision in part 1 was that the project is what? Viable. So in this case, we are looking by how much percentage we need to change the initial outlay so that we say that the project is not what? Is not viable. And that means that we make the initial outlay worst. You know, for the initial outlay, it is when you increase it that you reduce your NPV, and so it is what's reducing NPV that we will say that the project is not what? Is not viable. The 6% means that if we increase the initial outlay by at least 6%, by at least 6%, the project will not be viable. The project will not be viable. So that Ian, is that okay?
Yes.
So that Ian, is that okay?
Yes, yes.
Yeah, Brian, I can see that you've joined class. Welcome to today's class. We hope that you are fine, Brian.
Yes, I'm fine.
All right, so we can actually test what we have said here. We can actually test this, that if we increase the initial outlay by at least 6%, then we'll say that the project is not what? Is not viable. And so to test on this, I'll come here and say that test. I'll come here and say that test. I'll come back to this info that we had before. Beside it, can you just add this test thing? And so the first thing that we will test is the initial what? The initial outlay. The initial outlay. Now, what did we say about what happens to the rest of the factors when you change one? If I, for example, change the initial outlay, what did we say should happen to the rest of the factors? Yes? What did we say should happen
constant.
to the rest of the factors? Yes, Brian?
They should remain constant.
Yes?
They should remain constant.
Yeah, they should remain what? Remain constant, yeah? So let's agree. If these are the values for all the factors, when we are assuming when we change the initial outlay, which is this figure, yeah, the 500,000, everything else remain constant. Everything else does not what? Does not change. That means that the total present value for the other factors remain at this 532. That does not change. The only thing that we are changing is this initial outlay. And we are in this case saying that if we increase it by at least 6%, then the project will not be what? Will not be viable. And so in that case, what I want us to do is to increase this 500,000, the initial outlay, by 6%. And remember, increasing by 6% will mean that I copy this, I copy that. So increasing by 6% means that we multiply by, let me do in bracket 100% plus this 6%. I am doing that because this 6% could not necessarily be 6%. It could be maybe 5.9%, which Excel rounds off to 6. To ensure that you pick the right percentage, then I'll say that 100% plus this, more or less like times 106%. That gives us that figure. That gives us this figure. That is what that gives us. And if that increases to that, let's now check on the new NPV. If you check on the new NPV, you realize that we end up with how much? We end up with a 0. We end up with a 0. Where NPV is 0, you can actually say that the project is not what? Is not viable. The project is only viable when your NPV is positive. At the point you compute an NPV which is 0, then you can actually reject the project. And so this confirms that this sensitivity analysis which we are carrying out here, based on this interpretation, is there for what? True. Is there for true. And so that is there any question on that? Nani yako na swali?
Excuse me, sir.
Yes.
I beg to know what we are actually doing. Since I'm late for class, I apologize, please, but I would like to know actually where we headed to from when you started, kindly.
We started 30 minutes ago. Okay. We started 30 minutes ago. And what we are doing is, you remember in the last class, we had a question which we only attempted partially. Do you remember this particular question?
Yes, I remember.
Yeah, so we had only solved part 1 of it, where I taught you how you compute NPV, both based on the function and based on what I had called the long approach. The long approach is what today I started by repeating here. That for every cash flow, first compute the present values. So you have this. First compute the present values. And then of course from there proceed to compute NPV by minusing this initial outlay from that total present value. So that we did in the last class, remember, so that was more of a repetition. What we are now doing is part two of this question, which is requesting we compute the percentage change. And I've said that the percentage change is the same as what we can also call sensitivity margin, because what we are currently doing, remember, is sensitivity analysis. When then you are told to compute the percentage change, that reverses the decision which you made in part 1. You know, in part 1, we had said that the project is viable because NPV was what? Positive. In part 2, we are now looking for the percentage change in these factors. You know, these are the factors we consider to compute NPV. When any one of them is changed, NPV must what? Change. So what we are looking at is very simple. By how much do we need to change these things so that we reverse this decision in part 1? If the decision in part 1 was that the project is viable, then we are looking for the percentage change in these things that will make us say that the project is not what? Is not viable. To compute a percentage change, this is the formula which you apply. So based on that formula, we have computed 6% for the initial outlay. And because the initial outlay is a negative in computing NPV, we are saying that the 6% means that if we increase the initial outlay by at least 6%, then the project will not be what? Will not be viable. And that is what I have tested here. When we assume that it is only the initial outlay that we are changing, then what changes is the value of the initial outlay from this 500,000 to now this 532, if we increase it by this 6%. Because the rest of the factors remain constant, then we are saying that this total present value, this one, does not change. And so that's why here I have this total figure. So when then you compare the total PV against the increased initial outlay by 6%, you end up with a new NPV of how much money? You end up with a 0. So that is the recap to where we had stopped with you. And of course, what we have done today in the time that you are not in class. So is that okay?
Okay, sir. I appreciate.
All right. So let's compute for the salvage value in the same manner, yeah? And still we are saying that this is the formula. That's the formula for it. That's the formula for computing the percentage. Like now for the salvage value, this will say that equals what? This will say that equals, you know, the formula is NPV over this. So we take NPV again. This 32 something, we divide by what? We divide by the present value of the salvage value. The salvage value is, was this 80? The present value for it, we have this 52. So you divide by 52, 601. You divide by the present value for the salvage value, the 52601. And so the answer that we get is about 60 what? 61%. That's about 61%. And what does the 61% mean? I want somebody to try and interpret for us what the 61% means. Remember that in computing NPV, the salvage value is actually a plus. Unlike the initial outlay which we started with, which is a minus, the salvage value is a what? Plus. So what's the interpretation of this? Somebody, what is the interpretation of this? If this is now a plus in computing NPV, then we make it worse when we decrease it. So that if the salvage value, is now decreased by at least 61%, again we conclude that the project is not what? The project will not be what? Will not be viable. So the project will not be viable. That is what that means. And what we can do, gentlemen, is to come back to this testing part, you know, like we tested for the initial outlay, I now want us to test on the reduction of the salvage value by at least that 61%. And in this case, what we shall change is this salvage value. The salvage value shall now be how much money? The salvage value shall now be this 52,601. That 52,601, we multiply by what? We multiply by, so we want to decrease by 61%. We multiply by about 39%, yeah? That is once you remove 61, but I'll say in bracket 100% minus this 61%. So we end up with that other percentage. We end up with that other percentage. So what we get is about 2522.73. That's what we get. Now, please remember, everything else in the rest of the information remain the same. Everything else, you don't change them. Like now for the sales value, we shall still have this 1.3. For the sales value, we shall still have that 1.3. And then for the variable overheads, we shall still have the 799. The fixed overheads, we shall have this 91. When you add them downwards with the new salvage value, the total new present value comes to how much? 500,000 shillings. We do not change the initial outlay as well. So the initial outlay will remain at what we had before. Now this 500,000. So that 500,000. So again, when you compare the total PV, which is this, and the initial outlay, your new NPV becomes how much? 0. Becomes 0. That's how we have then tested on what? The salvage value change. And so is there any question on that?
Excuse me, sir.
Yes.
My question literally draws us back to the previous formula, which you referred to as a short way of doing it. So of literally finding NPV. So I'm settled that if I try to use this formula, does this mean that I won't be able to get the sensitivity since I can't be able to see if it draws us to present values of these factors? It only gives us a general net present value, but doesn't give us the PVs.
Yes, so in the event you have this sensitivity thing, yeah, then you'll be forced to come up with these present values, because in carrying out what we are doing, in doing this sensitivity analysis, you need the present value of each of the cash flows. So when you work with the short way, you do not get the present values. So it's advisable that apart from knowing how directly and shortly you compute NPV, can you also know how to get these present values, so that when you come to this kind of a thing, then of course you are safe. You are safe in terms of you are in a position to get the present values. Sawa sawa. Yes. Are you guys there? Is that okay?
Yeah, it is okay.
All right, so if that is okay, then I want to give you work. I want you guys to now finish on the other three, plus the associated interpretation. So calculate for the other three, plus the associated interpretation for this. So complete on that. I think I can give you like 5 minutes. Complete on that, plus the associated interpretation. So please do that. Yeah, so when you are done, please gives me a heads up that you guys are done. As soon as done, please give me a heads up. Yeah, so I can see Ian saying that he's done. You can see Ian confirming that he's done, yeah? What about Brian? Brian, are you also done? So thank you very much. I think with that we can proceed to required part 3. With that we proceed on to required part 3, yeah? Proceed on to required part 3. And what does part 3 want? Let's look at what's required in part 3. Yeah, so part 3 of the question says that we calculate what we call the internal rate of return, and then we proceed to advise on the project viability. Yeah, so let's proceed on to calculate that so that we are looking for the IRR and what? And viability. You guys should be able to compute the internal rate of return. So very quickly, what percent are you getting? Very quickly, you are getting what percentage? Please compute it based on the information that we had for the short NPV. For the short method of computing NPV, we had those summarized cash flow per year, yeah? Work with those cash flows. I think somebody to very quickly remind us of what cash flows were they. How much was it period 0, how much period 1, how much period 2, and how much was it period 3. So that was how much, somebody? period 0, the net relevant cash flows, the net relevant cash flows were how much per year?
$500,000, negative 500,000.
So that is period what? Period 0, is it?
Yeah.
Yeah, so period 0 we had negative 500,000, followed by how much was it in period 1?
210,000.
210? 210,000. What about period 2?
210,000.
210,000. Period 3, that was 200 and what? 30?
No.
Or 90?
290.
290,000. Yeah, so those were the cash flows, remember? Those were the cash flows. I can see Brian already confirms that the internal rate of return, that is 19%, yeah? So from these cash flows, how much internal rate of return do we get? Let me hear from Brian. Brian, you are getting what percentage as well? Is it Brian or Ian? Yeah, Brian is confirming that that's 19%. Ian, sorry, Ian, how much percentage do you get?
Is 19.
Also 19%, yeah? All right, so that should be very simple to compute in terms of this equals the IRR in bracket, these cash flows, and then I close the bracket, so about 19%. What is the project viability? Somebody? Is it viable or not? What is the project viability? Is it viable or not viable? Yeah, so in the chat, Brian says that this is what? This is viable. So remember, very simply compare this 19 with the cost of capital by the company, yeah? And because this is more than the cost of capital, then of course we conclude that the project is what? Now viable. Allow me to ask whether, or let's first of all do number 4, yeah? Let us first of all do required number 4. We first of all do required number 4. And number 4 says that if the initial outlay and the salvage value were to adjust adversely by 20%, calculate the new internal rate of return in each case and advise on the sensitivity of what? The project. So number 4 is looking for what we can call the new. Number 4 is looking for what we can call the new internal rate of return if the initial outlay and the salvage value are adjusted adversely by 20%. So in that case, we want to look at sensitivity analysis, but of course in terms of the internal rate of return, assuming we change one variable by so much percentage, in this case 20%, we are looking at how will our internal rate of return change from this 19%. Let's start by, let me call it the first one, and start by the new. We look for the new internal rate of return. If let's start with the initial outlay. So if the initial outlay is adjusted adversely, by 20%. Now, what does it mean to adjust the initial outlay adversely by 20%? What does it mean? What does it mean to adjust the initial outlay adversely? What does that mean? Does it mean we increase or does it mean we decrease the initial outlay?
I suppose this means we decrease the initial outlay.
We
decrease the initial outlay.
We decrease the initial outlay.
Yes.
When you decrease the initial outlay, you know the initial outlay is a negative cash flow. Okay? And the word adverse means that we adjust to the bad. We adjust to the bad. So when the initial outlay is a negative cash flow, adjusting it to the bad means that we increase it. You know the initial outlay is money which we will spend. Adjusting it to the bad means that we do what? We increase that expenditure. So adjusting the initial outlay by 20% means that increase the initial outlay by that 20%. I will say that the new cash flows, will be how much? So again, period 0, period 1, period 2, period 3. The initial outlay is what applied to period what? The initial outlay is what applied to period what? To period 0, yeah? The initial outlay was this 500,000. The initial outlay was that 500,000, yeah? We are saying that we are adjusting it adversely. And I've said that being a negative cash flow, to adjust adversely means that we increase it. So I'll take the 500,000. To increase by 20% means that we multiply by 120%, so that the new one will be 600,000 shillings. Appreciate that the rest of the cash flows will not change. Under sensitivity analysis, we only change one factor at a time, yeah? We only change one factor at a time. So the only one that we change is this one for period 0. If that is the case, what is our new internal rate of return? How much is the new internal rate of return? Yeah, so Brian says that this will be 8%, yeah? The new one will equal IRR in bracket all the values. Close the bracket. Truly, we have 8%. So truly, we have 8. We have 8%. All right. So in the same manner, we look at number 2. We look at number 2. Yeah. We look at number 2. We are again looking for the new internal rate of return. If the what? Now the salvage value. If now the salvage value is adjusted adversely. Is adjusted adversely by 20%, is adjusted adversely by 20%. Begin by looking for the new cash flows. Begin by looking for the new cash flows. Begin by looking for the new cash flows. So again, period 0, period 1, period 2, period 3. The cash flow for period 0, you know, is the original 500,000. That is now not changing. The salvage value only applied to which period? The salvage value only applied to which period? Somebody? The salvage value affects the last period, remember, which in this case is period 3. So the cash flow for period 1 will not change. What we had before, the same as the cash flow for period 2, that also will not change. When we come to period number 3, when we come to period number 3, you know, it will be the 290. The 290 now. What does it mean to adjust the salvage value adversely by 20%? You know, the salvage value is now a cash inflow. Adverse is to the bad. To the bad or to the adverse means that what do we do to the initial outlay? Do we increase or do we decrease? Yeah? Do we increase or do we decrease the...
We will decrease.
Yeah, you decrease the initial outlay. Yeah? Now, I will therefore take the 290, the whole cash flow, which we had computed for period 3, I will minus from it. You know that whole cash flow had the salvage value. So it had the salvage value, which was how much? How much was the salvage value? The salvage value was this 80,000 shillings, this one here. So the salvage value was 80,000 shillings. So that we are decreasing that by 20%. We are decreasing that by 20%. So I take the whole of the 290, the total cash flow period 3, which has the 80,000 shillings, the salvage value for period 3, but then you decrease by 20% of that 80. How much cash flow do we now have for period 3? 274,000. We can therefore again compute our new IRR. And what percent do you get?
Excuse me.
Yeah, so Brian says that this is 17%. What about Ian? Yes, Ian, you have a concern. Go ahead.
The period 3, just go to the formula.
This one for period 3.
Yes.
Yeah, so I've simply taken this cash flow for period 3 that was plus the salvage value, yeah? So nikachukua hii period 3 total cash flow. It had included the salvage value. So what I've done is just to minus 20% of the salvage value, which was 80,000 shillings. This LG25 is the salvage value from before. That 80,000 initially from the original question. So that's how I've computed that. I've just reduced the total cash flow by 20% of the salvage what? Salvage value. So is that okay? Yes?
Yes. Yes.
All right, so if that's okay, then that's it. So Ian, how much percentage do you have for the internal rate of return? Or rather, how much is your new internal rate of return? So that should be equal to internal rate of return in bracket all the values. Close the bracket. That gives us about 17%. Yeah. So that gives us about 17. That gives us about 17%. All right, that is it for required number 4. So that is it for required number 4, yeah? All right, had we talked about how to show the internal rate of return using a graph? And I think somebody had asked about
We haven't seen that.
Yes?
We have not seen that yet.
Or we haven't done that, yeah? Yeah, so we have computed, forget about this part 4. For the question, we have computed that our internal rate of return is 19%. What if you are told that to show this, but then using a graph? What if you are told that determine the internal rate of return, but then using what? Using a graph. Let's look at showing or determining internal rate of return using using a graph. So showing or determining the internal rate of return, but then using a graph. Now, how did we define the internal rate of return? You know, we had said that this is the same as the discount rate. The same as the discount rate at which what? At which NPV, at which the net present value equals what?
Zero.
We had said that the internal rate of return is the same as the discount rate at which we have how much NPV?
Zero.
Yeah, 0, yeah? So at which NPV equals what? 0. All right, if that is the case, then now our internal rate of return we had determined at what percent? Remember at 19%. Now this is what I want us to do, yeah? What is the relationship between the discount rate and NPV in terms of what happens to NPV as we, for example, increase the discount rate? How does the discount rate and NPV relate? Normally, the discount rate and NPV, the discount rate and NPV relate inversely. They relate inversely. And what does an inverse relationship mean? An inverse relationship means that when one is increased, the other one decreases. That is what we call an inverse what? Relationship. Yeah, so that allow me to have a comparison between the discount rate and NPV, so that I will do 2 columns in which I want to make that comparison. And allow me to say that when the discount rate is 0%, there will be so much. So this is a discount rate, and then here is NPV, not rate again. If the discount rate is 0%, there will be so much NPV. Let's make an assumption that we increase this to 5%, and then we increase to 10%. So very simply adjusting this by 5%, and then we increase to 15%. Now, the NPV that we computed before was how much money? Not NPV, but the internal rate of return. The IRR that we computed before, remember, was 19%. Remember, was 19%. So after 15%, if I increase by 5%, I'll go to 20. But because we know that our NPV is at 0 at that internal rate of return, Then I'll say that the next percentage is equal to, now is equal to what? Is equal to, I copy the IRR, which we had before. So that's 19%. But obviously, I know it's not 19%, it must be 18 point something. That's why I am copying directly. And then so from 15%, if we increase by 5%, we go to 20%. And then if I again increase by 5%, I will go to another, say 25%. And then I can leave it at that. I can leave it at that. What I now want us to do is to calculate how much is the figure for NPV when these are the discount rates. How much is the figure for NPV when this is the discount what? Now rate. Remember that like what? Like for the discount rate at 0%, NPV will equal what? So you say equal to NPV in bracket. Now look here, do not type the 0. Can you pick it from this cell directly? Copy from the cell for the 0 directly. And then we comma, and then we comma, and then we comma. Now, what were our cash flows? The cash flows were these ones. The cash flows were 500 year 0 to 10 year 1 to 10 year 2 to 90 year 3. So we normally pick the cash flows period 1 to 3. And then we close the bracket and then say that plus the initial outlay. So work with the original cash flows. Work with the original what? Cash flows. The original cash flows are these ones that we used to compute this 19%, yeah? The IRR. So that if the discount rate is 0%, then our NPV we have 200 and what? 10,000 shillings. As you then continue to increase the discount rate, because their relationship with NPV we have said is inverse, then the NPV will keep doing what? Keep reducing. So then the NPV will keep reducing. And so how much is the NPV at the next discount rate, which is 5%? So how much is the NPV at now? 5%? The NPV at now 5%. How much is that? Remember, the cash flows remain constant. The cash flows are not changing. So the only thing you change is the 5%. Actually, what you can do is, let's work with the formula for NPV at this 0%, yeah? I will go to the formula for that 210. Now, in this formula, the only thing we are changing is the first cell. In my case, that is C67. That is the cell that we will keep changing, that cell for the discount rate. The rest of the cells will change. The rest of the cells will not change. The rest of those variables will not change. So the rest of the variables will not change. The rest of the variables will not what? Will not change. If the rest of the variables will not change, then we can lock them. Then we can lock them. And I don't know whether I've taught you this locking thing. Have I taught you how to lock variables which are constants? Yes?
No.
Not yet. In this formula, I am saying that our cash flows will not change. All these from F45, H45, and E45, those ones will not change. They will remain constant until the last what? The last percentage. The only thing that will keep changing is that percentage thing. When a cell does not change, when a figure does not change, you can lock the cell. You can lock the cell, yeah? So like in this formula, all these are not changing. So I want to lock cell F45, I want to lock cell H45, I want to lock cell E45. To lock a cell, you normally put the $sign before and after the letter for a cell number. Like in this case, this is what I'm saying. F45 is a cell in my case. That's a cell. If I want to lock F45, if I want to lock F45, before F I put $, and then after F I put $. I've said you put the $sign before and after the letter. So I put $, before F and $, after F. The same thing I do for the next one, H. I put the $, before H and again the $, after H. Then the last one also, E45, I put the $, before E and again I put the $, after E. Then I re-enter. So what I've done is to make the cash flows constants, so that the only thing that will change are these percentages. So once I've done that, I can simply drag the formula in this 210. The formula in this 210, I simply drag it to the last discount rate. And ladies and not ladies, there are no ladies in this class. Gentlemen, when I do that, remember, these are the NPVs which I get. I now have NPV from the first percentage to the last. So that please confirm that you have been able to do that. Yes? Have you been able to get all the NPVs to the last?
Yes.
All right. So if that is the case, then you can see that at this discount rate of 19, that's where your NPV is at 0. And so this 19 is what we consider the internal what? Rate of return. But of course, what the question wanted is that we show the internal rate of return on a what? On a graph. On a graph. So we therefore have to come up with a graph for this info. We therefore have to come up with a graph then for that info. And so, do you guys know how to come up with a graph? Now, what we will do is this. I think, highlight a cell, maybe hapo kando ya that information. Highlight a cell first, the way I've done. Highlight one of the cells, just one. Highlight any cell. And then, if you want a graph, if you want to do a graph, you come to these options up here. The options at the top of your Excel, graphs are normally under insert. So you click this option insert. So you click that option insert. When you click the option insert, you are brought for a lot of options. One of the options is these charts. You can see the charts mahali. In this case, we shall do a line. We shall do a line chart. Chart and graph are similar. A chart, a graph, we are talking about the same thing. So normally we have many types of charts or graphs. You can have the column graph, the line graph, the pie chart, pie graph, the bar graph, the scatter graph, and you are told other charts. But in this case, what we want is this line. So you'll click on the line.
Excuse me, sir.
Yes.
Apparently, I got the first one correct, the LPV, but the following one, upon dragging, is giving me a different answer from what you got.
You haven't locked your cells properly. Click on your formula and check whether you've locked the cells properly.
Okay, I just locked the cells from, I didn't lock the cell reference for the rates, but I locked the other cells for the amounts, for the cash flow, for the net cash flow.
Do you see what I've done? The first cell, C67, I haven't locked. Why? Because that is the discount rate. It will keep changing from 0 to 25. So don't lock that one, but lock the rest. Lock everything else. Before the letter and after, you have 3 letters. You have 3 other cells, so you'll have 3 letters. Before and after those 3 letters, can you put $? Did you do that?
Yes.
And then you re-entered.
I'm now getting the right answer after following what you've done.
Oh, so you now have the same figures as mine, yeah?
Yes.
All right, so we can proceed. So we are coming up with a graph. I've said that you highlight one of the cells, hapo kando. You highlight one of the cells, and then at the top of your Excel, I have said that graphs are normally under the option insert. So up here you have file, you have home, and then you click insert. When you click the insert, you are taken to where you have so many options. One of the options ni iko hapa katikati, the charts. A graph is the same as a chart. There are several types of charts: the column chart, the line chart, the pie chart, the bar chart, the scatter chart, others. So I'm saying that let's go for the line chart. So click on it. When you click on the line, you are again shown a lot of options. When you click on the line, you are again shown a lot of options. You are shown a lot of options. I want you to click the first one, the first option in those options. So when you click on the first option, has your Excel done what mine has done? Have you been shown some window inside your Excel, a blank one? Yes?
Yes, yes.
All right. So that blank area is what is called chart area. If you put your cursor within that blank area, it is called the chart what? The chart area. And by the way, you can move this thing the way you want. You can move it. You can move it so that it does not block any figure you have computed before, yeah? So this is the chart area. This is where we want to have our graph or our chart. Why is the chart area blank? The chart area is blank because we have not yet put any data in it. So we need to put this data so that a graph forms inside here. And how do you put this data that we want to plot in a graph in this chart? You will right click. And when you right click, you are given these options: the cut, the copy, reset to match the font, change chart type, select data. Now, please pick that select data. Click on select data. Click on select data. When you click on select data, you are taken to this kind of a window where you have select data source and then chart data range. And then what do we want to do? We want to add data to that graph that we are preparing. How do you add data? Look to the left of that window. There is this option, add. Look to the left. There is that option, add. So click on add. You will click on what? Add. When you click on the add, you are taken to another smaller window where you have edit series. Below that, you are told that first we need series name. The series name here is we are plotting NPV because at the IRR, we know that NPV is what? 0. So the series name, you will type NPV, then you come to the series values down there. Put your cursor there and delete what is there. That equal to one thing. Delete it so that it is totally what? Blank. The series values, our series name is NPV. The series values are the values of NPV that we are saying is the series name. So I'll pick the series values, the values of NPV, which are these ones. So I'll pick all of them from the first to the last. I will pick all of them from the first to the what? To the last. And then you'll go back to the small window and press OK down there. So press OK. So when you press OK, you are taken back to where? To that big window where we had the add whatever. Now, sometimes what you are plotting could be two or more variables. Like you can have NPV, you can have profit, and so on and so forth that you are plotting against this discount rate. If you have two or more variables, then you'll again just come and say that add again. You'll add again, maybe this could be profit. And then you pick the values for profit. But we didn't have a second variable. That was all. So we are taken back to that big window. You know, we have only input the values for this NPV. We have not yet put the values for the discount rate, because we are plotting NPV against the discount discount rate. If that is the case, then of course you'll come back to this window again. On the right hand side, you have the part called edit. On the right, the part called edit. So click on it. Click on it. When you click on it, you are taken to a smaller window called the axis labels. And then we are told that we have axis label range. The axis label range are the figures for what you are plotting the NPV against. And the figures that we are plotting the NPV against are those percentages. So select all the percentages, 0 to 25, 0 to 25, 0 to 25, come back and press OK. So you come back and press OK. And then again, you are taken back to the bigger window. Finish by pressing OK down there. Down there, you have OK again. Click on it. When you click on it, that is the graph that we come up with. That is the graph that we come up with. That is the graph that we come up with. Now, allow me to remind you that at the point that NPV is equal to 0 is the point that we do have the internal rate of return. This graph has plotted, the curve is an NPV curve. That's why beside here, you are told that the curve is NPV. So this is an NPV curve plotted against various what? Percentages that way, percentages that way. At the point at which the NPV curve touches on the x-axis, at the point it touches on the x-axis, I think that's somewhere where I've put my cursor, somewhere there is the point at which the NPV curve touches the y-axis. You know that point is 0 in terms of NPV. So at that point, if you put your cursor will be showing you that you have approximately 19%. Approximately 19%. And so, gentlemen, that is how you show the internal rate of return on a graph. That's how you do it. And so, is anybody having any question?
Yes, I have two questions.
Yes.
So first of all, it means you must have the IRR calculated first, and then you make a sort of like this table.
Yes.
Which among those values you have IRR. So this one you first you calculate it first, and then
Yeah, compute it first using the normal formula, yeah? So that you have an idea at what point you will have that IRR, yeah? Then using approximations like we have done here, we have increased our percentage by 5%. Have those percentages that way. One of them would be the IRR, which should fit somewhere. Like in our case, that should fall between 15% and 20%. And so that when you come up with a graph, then the curve for NPV should touch the y-axis at the point at which you have that 19%. So first you just compute the IRR using the normal formula. What is your second question?
Yeah, so when you're deciding, so is a rule when you make sure that on the x-axis you put the independent variable.
Yes.
Okay.
Yes. On the x-axis, you must have the independent variable. In this case, the percentages that are determining NPV, which in this context is the dependent variable. So you must always ensure that on the x-axis you have the independent variable. Sawa sawa.
Okay, thank you.
All right. So if that is it, if there is no other question or concern, then that is it for how to determine NPV.
Okay, my question is,
yes.
Do we have an alternative way of calculating the NPV, maybe by use of is it sensitivity data table? By use of data table and format cells, and is it under data tab?
No, I'm not quite sure, but I haven't come across that. Yeah. For
Okay.
NPV, we have to stick to the two approaches which I've taught. Yeah.
Okay.
Yeah. Otherwise, in terms of whether there's another formula, I am not very sure. Could be there is, but I haven't come across that.
Because I remember the time when we were doing this, and then we were using something. When we go to data table, then you go to what if analysis. There is that data table whereby we could use either a two table analysis, or maybe a one table. Like now this one, we were using something like one table, though I can't recall it clearly. Though with time, if I have to redo it, I may find it well how we used to do
that
it.
would be detailed statistics. Yeah.
Yeah.
That would be detailed statistics, which is not a requirement. You know, this Excel has so many things. Yeah. It is actually impossible to know everything in it. Virtually impossible. You come to it and only look for what is relevant for what you do. So some of those other alternatives, I would be honest, that could be existing, but unless we are looking at such detailed statistics, then we do not need to know them. Sawa sawa.
Sawa.
All right. Now, have we looked at the payback period, and have we looked at the payback period and the profitability index?
No.
Or not yet, yeah? So if that is the case, then we shall look at the payback period. The payback period. This we can abbreviate as a PBP, yeah? the payback period PBP. And then also very shortly, we shall look at what we call the profitability index. And what is a payback period? How did you define a payback period?
Okay, I would say payback period is the period in which it takes a project to return its initial outlay, or to return back the investment which was pumped into that project.
Yeah, so precisely, this is the period that a project takes. This is the period that a project takes to recover. The period that a project takes to recover the initial investment. This is the period that a project takes to recover the initial investment, yeah? And when is the payback? You know, the payback period is also used to evaluate projects. You know that you can, for example, compare 2 or more different projects and make decisions based on the payback period. When do we consider the payback period best? Is it when it is small, or is it when the period is a lot of time? Which is which? Which is which? Are you happy when you take longer to recover your initial investment, or when you take shorter time?
When you take a shorter period.
Yeah, when you take a shorter period, yeah? So that in project evaluation, the less the PBP, the better. So the less it is, the better. The less the payback period, then of course the better. The less the payback period, then of course the better. All right. I want us to do this, and or rather, before I even look at an example, yeah, the profitability index, because this is also very simple. The profitability index, which is also a project evaluation criteria, yeah. What is a profitability? What is a profitability index? When I talk of a profitability index, what does this mean for projects? So this one is normally a measure. This is a measure of what we can call the profit potential. This is a measure of what we can call the profit potential of a project. This is a measure of what we can call the profit potential of a project. It normally shows, this one shows the what? This one normally shows us the profit to be made for every what? For every coin. For every coin invested, for every coin invested where? In the project. Shows us the profit made, the profit to be made for every coin that you do what? That you invest in a project. And what normally happens is simple, yeah? That a project is actually considered viable. A project is actually considered viable if what happens? If the profitability index PI is more than what? More than 1. So a project is normally considered viable if the profitability index is more than what? More than 1. So a project is normally considered viable if the profitability index is actually more than what? More than 1. The profitability index is normally computed as what? If you want to compute this, then you shall take the present value, then you shall take the sum. Let me just call it a present value of cash flows of the project. The present value of the cash flows of the project. You divide this by the initial outlay. So you divide this by the initial outlay. So that's how we compute the profitability index, the PI. This is closely related to what? This is closely related to, so this is closely related to NPV in the sense that we calculate NPV as what? We normally compute NPV as, of course, the present value of cash flows. We normally compute NPV as the present value of cash flows. Remember minus the initial what? The initial outlay. And this has to be very clear that the profitability index is somewhat related to NPV, in the sense that as you calculate NPV, you do take present value of cash flows, you minus the initial outlay. Whereas for the profitability index, you take the present value of cash flows, you divide by the initial outlay. So let me say that example. Let me say that we have example. So consider the following. Consider the following info. Consider the following info about. Let me talk of project X. And below this, we'll say that we have year, and then we have cash flow. We have year, and then we have cash flow. Of course, we do start with year 0. We can have year 1, year 2, year 3, probably year 4, and probably year 5. let me have cash flows like 10,000 shillings, the first one, followed by so 10,000 shillings, the first one, followed by 2,000 shillings year one, 3,000 shillings year two, 5,000 shillings year three. We can have 4,000 shillings year four, and then we can have maybe 3,800 shillings year five. So 3,800 shillings year five. I want us to compute. So what is required? What is required? Number one, we compute the payback period. Number two, we compute discounted. We compute discounted payback period. And then number three, we compute profitability. Profitability index. And then possibly you can add number four, you compute NPV. Number five, you compute the internal rate of return. So we should have the solution for it next. Should have the solution for it next. So we can take a breathing break of maybe 3 minutes, and then we resume from there. A breathing break of 3 minutes. All right, so we can continue, yeah? Can continue. And the first requirement under the solution, the first requirement is that we compute the payback. The payback period is that we compute the payback period. The first thing that we need are these cash flows, and so I will copy paste them down here, and we can estimate by looking at the cash flows the complete years that we'll need to, of course, recover the initial investment. You know, the initial investment was this negative 10,000 shillings. And so how is this recovered? We shall need the cash flow for year one. We shall also need the cash flow for year two. And then, of course, full recovery then happens in year what? Now year three. Allow me to change one of the cash flows. Allow me to change the cash flow for year three. Make that to be 4,000. Make that to be 4,500. Make that to be 4,500 instead of the 5,000. So make that to be 4,500 in case or instead of the 5,000. Yeah, so that I was saying that we can know roughly, we can have an estimate of in which year the whole 10,000 is recovered fully. Like I was saying, we shall need the 2,000 for year one. We shall need the 3,000 for year two. We shall need the 4,500 for year three. And I want to believe that it is when you are in year four that the full recovery for the 10,000 shillings does what happens. The first recovery happens in year one. And if in year one we receive the 2,000 shillings, that positive cash flow, you know that settles, but just part of the 10,000 shillings, which means that we will have a remainder of the 10,000 shillings to be recovered in the periods which follow. And so you will add a column that let's call the remainder. Of course, in period 0, that is when we invest the 10,000 shillings. When you come to period 1, you know we are now recovering 2,000 shillings, which means that out of the total investment of 10,000, what will remain will be 8,000 shillings. Now, how can we get this remainder directly? I'll say that equal to the 2,000 shillings that we are recovering in year 1 plus the initial investment. So that even if we recover the 2,000 shillings in year number 1, still there will be a remainder for the initial investment of how much? 8,000 shillings. And so you can compute those remainders that way to the last year. You can compute those remainders that way, remember, to the last year. If we compute similarly to the last year, then I'll simply drag the formula for this 8,000 for year 1 to the last year. So that is how that recovery then happens. The full recovery, 100% recovery, happens in the year in which you see the first what? First positive. Like now we are saying that we will fully recover the 10,000 shillings in year what? Year 4. In year 4. But the fact that year 4 has a positive means that we do not need the whole cash flow. We do not need the whole cash flow for year 4 to recover the balance of the 10,000 from year 3. Look here, at the end of year 3, only 500 shillings is left. Meaning that when you come to year 4, out of 4,000 shillings, what you need is this 500 that is left. That means that we do not need the whole of year 4 to therefore recover the remaining balance, which was 500 out of the total initial what? Initial investment. For that reason, we shall agree. For that reason, we shall agree that the payback period is how many full years do we need? We need year 1, we need year 2, and we need year 3. We need year 4, but not the whole of year 4. That's why you remain with a positive 35 in year 4. So the full number of years that we need are there for 3 years, year 1 to 3, and then part of year 4. The payback period is therefore determined as what? I'll say that equal to what? 3, the full number of years that we need, plus we only need part of year 4. How do we get to know the part of year 4 that we need? This is how you get it. At the end of year 3, the balance left is only 500. So we need the proportion of that 500 of the total cash flow received in year 4. If in year 4 we are receiving 4,000 in total, out of 4,000 we need just 500. So we therefore need 3 full years plus a proportion of year 4, which you determine as this 500 left in year 3, you divide by the total cash flow received. Now then in the next year, year 4, which is this 4,000 shillings. So that is therefore 3 plus what? That is therefore 3 plus. This 500 is a negative, so I'll make it a positive by saying that negative the 500. But I need the 500 as a proportion of what? The total cash flow for year 4. So divide by this 4,000 to be received in year 4. The payback period is therefore 3.13. 3.13 what? 3.13 years. The payback period is therefore 3.13 years. The 3.13 years means that we have 3 years and then 0.13 over year. 0.13 over year is normally how many months? So it is 0.13 times what? Times 12. In terms of months, 0.13 is 1.56, more or less like 2 months. So the payback period is therefore 3 years, and around 2 what? 2 months. And around 2 months. And so that is how you determine the payback period. That's how you compute the payback period. Is there any question on that? So is there any question on how we compute that? Now, one of the main disadvantage or rather just one disadvantage of the payback period. One disadvantage of the payback period is not discounting cash flows. One disadvantage of the payback period is it not discounting cash flows. Remember, these are normally future cash flows, and so when we work with the future cash flows without discounting, whatever we get is more erroneous. You know, future values are not cash flows today, or other future values are not the same cash flows today. And so there is normally the importance of considering time value of money. Because the payback period does not discount cash flows, then we are saying it is one of the weaknesses that we have with the payback period. So let me say that, and hence, normally the need for what we call discounted. Normally the need for what we call discounted. Normally the need for what we call discounted. Normally the need for what we call discounted payback period. So normally the need for what we call the discounted payback what? Payback period. And remember, that's what number 2 wanted. That is what number 2 wanted. The discounted PBP. The discounted PBP should not be an issue per se, because importantly, what you do is to discount the cash flows and then compute the payback period in the same manner as we have done the first one, but now using the cash flows discounted. So what we'll do is to again copy that original information. Copy that original info, and then we have to discount and get the present what? The present values. What are the present values? What are the discounted cash flows for our cash flows? So let's get the present values. How do we compute a present value? We said that equal to PV equal to PV. And then in bracket, now, did I include the discount rate in the original question? No. Can you add to the original question that the cost of capital is 15%? Add that the cost of capital is 15%. Is 15%. I need that to compute PVs. And so that for the first one, the initial outlay, the present value, what is it? So PV is equal to, of course, the discount rate, which is 15%, comma, NPA is the period. NPA is the period. So in this case, I will select that 0. So I'll copy directly, do not type, because I just want us to apply a formula. going downwards. So select the 0 and then comma, because these are single cash flows, because these are not annuities, then we agreed that you will have a 0 and then you comma. If they are annuities, then you don't add that 0. But because these are annuities, then you put a 0 and then you pick the cash flow. You pick the cash flow, but this is what we are going to do. You know, when you enter, look here, you will have that present value as 10,000 fine, but the initial outlay should always be a negative. In this case, it comes as a positive because it was initially a negative. Now we need to make this a negative because the initial outlay, that's always a negative. So you'll go back to the formula for that present value, and before the cash flow, before the last cell, introduce minus. Before the cash flow, just introduce negative. So when you press enter again, we now have negative what? 10 million. We now have negative, actually 10,000. We now have negative 10,000. And so I want to remove this dollar thing. I want to remove that dollar thing. So I'll highlight the 10,000. And then up here, hapa kumeandikwa currency. I click on that and say that general. And say that general, so that I just have 10,000 what? Negative. So once I've done that, then this formula for the 10,000 I will drag to the last year. That formula for the 10,000 I will drag to when? I will drag to the last year. So that formula for the 10,000, then I will drag to the last year. So that way we then have PVs for all the cash flows. Now, the discounted payback period is computed similarly as the one we have done in part 1. Only now that we work with the present values for the cash flows. We now work with the discounted what? The discounted cash flows. If that is the case, then we shall have the column remainder. The column remainder. You now know how to get that remainder thing. The initial outlay period 0 remain so 10,000. And then period 1, we said that you compute the remainder as what? The cash flow period 1 plus the initial outlay. So the remaining initial investment after the cash flow for period 1 is 8260. So like we did before, drag the formula to the last year. You drag the formula to the last what? To the last year. Look at what now happens. The first positive is seen in period 5. The first positive is seen in period what? Period 5. Meaning we need the first 4 years. We need the first 4 years. We need the first 4 full years plus part of year 5 to then recover the initial investment. I want you guys to tell me how long the payback period is. The PBP is now how long? That discounted one. The discounted payback period is now how long? Brian says 4.50. So that he has determined as equal to 4 years. The first 4 full years that we require plus the first 4 full years that we require plus what? Negative this 746.60 divided by this collection for year 5. That's 4.40. Remember years. So 0.4 over year, 0.4 over year will be 0.4 times 12. That's about 4.8, so about 5 months. So we therefore need complete 4 years and 5 months. Complete 4 years and 5 what? 5 months. So there is not so much difference between the normal payback period and the discounted one. The discounted one simply first discounts the cash flows. Then based on the discounted cash flows, you now work out the remainder. Then in the same manner, you compute the payback the discounted payback period. Note that the discounted one is normally more than the normal payback period. And actually, in terms of accuracy, the discounted payback period is considered more accurate. Why? Because it uses real or the realistic cash flows. The discounted cash flows are normally the realistic what? Cash flows. Otherwise, for the first one, which uses the cash flows the way they are, then you tend to have a problem with, of course, that first payback period. And so is there any question on the payback period thing? Is there any question on payback period? If there is no question, then we go to number 2.
Question.
Yes.
I'm sorry, I'm saying you're saying for the present value that you only add 0 when you add that 0 after comma
when these are single cash flows. Cash flows, you know, you normally have 2 types of cash flows. Annuities, which is the same amount paid per period for a number of periods. That's an annuity. And then you also have what you call the single cash flows. You see, like now, this 2,000 for year 1 is just for year 1. You don't have it in year 2. You know, when you have, if I have year 1, 2,000, then I have year 2, 2,000. Then I have year 3, 2,000. When you have the same payment per period for a number of periods, you call that an annuity. And getting the present value for this will be PV into the rate, like in this case, 15%, comma, NPA will be 3 years, because this is an annuity for 3 years. That's an annuity for 3 years, comma, I'll just take 2,000. I'll just take 2,000 and then close the bracket. In that case, I've not added that 0 because the 2,000 is one payment. So that's an annuity. Because it repeats, then you don't need to add a 0 after that 3. So the present value for these ones would be this 4566. If you compute moja moja, adding the 0, their total will be this. Je, kama tunaelewana?
Okay.
All right, so let's go back to number 3. And number 3 wanted the profitability. Number 3 wanted the profitability index. Number 3 wanted the profitability index. Number 3 wanted the profitability index. The profitability index, we have talked about the formula for it. And remember we have said that what is the formula for it? What did we say is the formula for the profitability index? Yes, somebody. What did he
present
say
value
is the
of
formula for
cash
the
flows.
profitability index?
The present value of cash flows divided by initial capital.
The present value of cash flows you divide by
Initial outlay.
you divide by the initial outlay. Yeah. Now you can get the present values as we already have them here, so it is that summation. The total present value is that summation, that which let me highlight in yellow. The total for the PVs without the initial outlay, remember. So the total for the present values without, because you are dividing by the initial outlay, that's what you get. 11 whatever. So this 11 whatever divided by the initial outlay is the profitability index. Now, alternatively, you can say that equal to what? You can say that how can you get the present values of these cash flows directly? This is how you can get it. So equal to, you can work with the NPV function. You can work with the NPV function. So that you say that equal to NPV divided by what? The rate of 15%, comma, the future values are these ones. The values for period 1 to 5, I close the bracket. I close the bracket. Now look here. Look here. You don't need to do this, but let me do it on my side. We are not through with this working. If I press enter, you can see that I get the same cash flow as what I have highlighted up here. So you can get the present values of cash flows based on the NPV function, just that way. And then we are saying that total present value we divide by. We now divide that by what? We divide that by the initial outlay, this 10,000. If you pick the 10,000 directly, you'll be picking negative 10,000, yeah? To make that a positive, then start with minus. So divide by minus 10,000, the negative. When you now press enter, that's our profitability index. So that's our profitability index, 1.11. 1.111. And what does this mean? The interpretation of this is that for every 1 shilling invested, for every 1 shilling invested, profit earned will be 0.11 shillings. That is what that means. Profit earned will be 0.11 shillings. For every 1 shilling you invest, the profit earned will be 0.11. Kwa kila shilingi moja you are investing, you will earn the profit of 0.11. Because this thing is more than 1, then the project is what? The project is viable. Let me say that because PI, because profitability index is more than 1. So that is there any question? Is there any question? Yeah, so if there's no question, then I think we will stop there for today. Let's continue next weekend when we pick it up from there. So I still have two issues to discuss under financial management. One is a scenario analysis, and then the second one is one is scenario analysis. The second one will be the loan amortization schedule. So with that, we shall be through with the area financial management. So those are the two issues left for us to complete on FM, on financial management. So if at all none of you has a question, then let me say thank you very much. We look forward to have a fruitful week. We look forward to seeing you again next weekend, yeah? All right, Santeni.
Thank you.